everything, right? I mean, like, what's the, I feel unaware. I mean, connectivity standards. Facebook's doing all sorts of things, right? To kind of expand internet access and improve its all sorts of abilities. I mean, when you start to think about this stuff from an infrastructure perspective, right? I mean, what's your
Yeah, so we've been, I'd say basically in the last year or two, we've been quite busy, as you mentioned. Whereas that for the first several years of Facebook, I'd say like the last maybe 3 or 4 years, we were really focused on just scaling the main app, right? And there was a lot of technology that was being built, software. Most of you are aware of the work that we've done in open compute and the hardware in the data center area. And I'd say in the last year or so, we've been really trying to invest and start thinking about these longer term technology bets for the company that have a longer arc, 3, 5, 10 years. Some of that is demonstrated in our acquisitions of Oculus, so investing in what we think is going to be a pretty significant computing shift with VR, and then eventually how that moves into AR, and investing in that. And that's going to have tremendous sort of infrastructure and hardware and software and networking challenges to make those experiences that we're thinking about with that product real, and to bring that out to people. And then the other part of this also is that with about 20% of the world's population, we think, is not able to connect to the internet, right? They physically just don't have the infrastructure or have access to connectivity. And we started this effort called Internetorg last August, I believe it was. And there's 2 parts to Internetorg. One is really kind of working on the business model side, working with the carriers to rethink some of the business models and how people use applications, how they use data, working with our carriers, working with our software developers, internal Facebook, making our applications more efficient so that we use the resources in the wireless networks more efficiently, be more cost effective to the consumers who are paying for data access. Fun story there is that last year we did a bunch of studies on our application and found that, and did a bunch of work on this, and we were able to decrease the amount of data that our applications, the Big Blue app, the main app, was consuming by 50%. And there's a lot of work there just in terms of streamlining the data that people consume when they're always on communicating, sharing with people. And then a few months ago, we launched another effort as part of Internet.org, really kind of thinking out, again, further 3, 5, 10 years to really address the part of the world's population that doesn't have access to internet. And this is our investments in our high altitude, long endurance planes. So we acquired a team of folks out in the UK, a company called Ascenta, and we're working on basically this high altitude technology that will be able to effectively beam the internet down to rural areas, places that are disconnected. And we think that we can do this in a way that's just going to provide a much more cost-effective and a faster time to market to getting internet access to folks. So we're investing in, obviously, the planes, as I mentioned, free space optics, so laser communications is a team that we've now started to build up and have some of the world's experts now working at Facebook to help with that connectivity, those connectivity challenges. So I think what you're seeing here, and I can go on, but with Oculus, with Connectivity Labs, the investment that you touched on just briefly before, and building out the team around AI and deep learning, is really us investing heavily in becoming what we think is, sort of a great technology company, so that we can basically focus on this mission that we have to connect the next 5 billion people.
All right, and how does what you do inside the data center have to change to accomplish that? Because these are very different workloads and sorts of things than just like I said, serving a Big Blue Facebook app, right? I mean, these are...
Yeah, so the needs inside the data center for us have constantly been changing over the years, right? As we've taken sort of a look to our approach to our data center has been one that where we want to start thinking about how to bring more flexibility in the data center. We want to have a better efficiency. We want to be able to use less energy. We want to spend less money on this. We want to be able to handle the scale that we were talking about today, with nearly 1.3 billion people using Facebook, and then we've got Instagram growing quickly. We've got Facebook Messenger. Once the WhatsApp deal closes, we have just a huge set of workloads that we're trying to build for and make sure that we're staying out ahead of. And so, one of our core philosophies that we've had is we think about our data center, our hardware, is about disaggregation, right? And this is something that we've talked about. It's been part of our contributions to the Open Compute project, which is now coming up on its third year. And we really think that if we can think about these bigger kind of pieces of infrastructure and break them up into more smaller kind of, Lego building blocks or sort of bricks, that we can kind of compose these things and sort of stick these things together over time. And it gives us more flexibility for how we need to handle, say, the workload on Messenger, right? So Facebook Messenger today handles, over 200 million people using the product. There's over, 12 billion messages being sent every day on Messenger. That's very different than, say, the Instagram workload, which is, all photos and photo sharing. It's a different social graph as well compared to the main app. So we have to be able to have like a data center architecture with the servers, with the network, et cetera, that allow us to sort of make sure all these product teams can move as fast as possible and grow as fast as possible. But we need to make sure that we aren't, that we're being flexible, but also cost efficient in how we build this out.
How much of that is a hardware question and how much is a software question? Because Facebook is famously built, and does still build a lot of software tooling and systems.
We really think about, it's a great question. We really think about our stack as a full stack, right? So the way that our teams are structured and they work together is such that the software teams are working side by side with the hardware teams, and the hardware teams are working side by side with the data center team, right? So we really don't think of this as like hardware versus software. It's here's the problem, here's the solution that we need to build, let's do the full stack. In fact, one of the things that we've focused on in the last several years is just really looking at a full stack optimization and trying to make our infrastructure more efficient. And over the last 3 years, we've actually saved over $1.2 billion by looking at sort of this full stack optimization that comes from working on changing how we build hardware, but also the work that we put into our software and making it more efficient and run more efficiently.
All right. And so, you mentioned earlier, Open Compute, which is coming on 3 years, and that's been moving fast, right, from servers to storage to data centers to, and then there's been talk about, right, a network switch, right?
Yep. So last year, it was about a year ago, we had started working with the Open Compute team at the project and announced a networking project so that we were going to basically look at how the top-of-rack switch, everybody knows sort of the top-of-rack switch and what it does, and how common it is in data center infrastructure. Obviously, you can put all the servers you want in a rack, but you can't actually do anything useful with them, and unless you have connectivity outside of the rack. And one of the things that we really kind of continuing along the theme of disaggregation was that we've done this for racks, for the compute part of it, for storage, and for other parts of our infrastructure. But there's this one lingering block, which is the network. And the network, it's still kind of been integrated into our infrastructure and just a conventional, like buy this box, put it in the top, plug it in, and configure it and go. But we were running into and have been running into just a lot of things that slow us down. It just doesn't give us the flexibility we want, the control that we want, the ability to configure things, monitor things, to adjust flows. As I talk about Messenger and Instagram and Newsfeed and search and all these different workloads that we have to manage, being able to manage that effectively on the network is like a very, very rich area for optimization. So what we've done actually since the Open Networking project, and that continues on, is inside of Facebook, we've been working on a design for a top-of-rack switch. So it further kind of, the Open Compute Networking project that we had kicked off last year really separated software from hardware, right? It was a very simple split. Here's the software, here's the hardware. Now, what we've done with our switch that I'll have some photos to show is actually take the software piece of it, split it into a bunch of modules, and then take the hardware and also split it into a bunch of modules, right? So we want to actually have more flexibility. We think that this is going to give us, sort of better cost, but also give us like much more flexibility in how we build our infrastructure, because we'll be able to innovate on these different components over time and be able to change things at a much more rapid rate. We'll be able to change software frequently. We'll be able to kind of change the chassis or change the different components inside the chassis based on what is available, what makes sense for us, and not having to kind of just think about the big black box.
Oh yeah, because this is designed to actually fit into the rack, right?
Yes, it is. It is. Should we show a picture?
Yes, I think so.
Okay. Let's see if it shows up. All right. That's our logo. All right. So here's our switch. It's born Facebook Blue. We've got basically 16 slots coming out the front here. It's a 40 gig switch, and this is what we started out with. This thing can, if we want to, expand to 32 ports as well. Now, once this goes into the rack, we'll have basically the split cables here so that we can feed 10 gig down to each server. And so we have a lot of flexibility with this, right? We can change things out. And to make it a little bit more interesting, here's kind of a split out of what the guts look like here. And you can see that the chassis is something that's pretty trim and neat here. There's some fans, a couple power supplies, and then the two really interesting things that I think about this is, one is that there is this microprocessor board here, and you can see it called the Open Compute Group Hug board. And really this is an Intel chip here, and the cool thing about this red little board here is that it basically takes this switch, and it's very, very small but very powerful for us in our infrastructure, and it turns this switch into, basically, as we see it as software engineers, it turns it into another server. This is no longer a switch as we think about building our infrastructure. It is just a server. So this basically runs, our Linux distribution has a bunch of our code running on in terms of monitoring, configuration, metrics, and other kind of ways to plug into our control plane and our fabric, and then it interacts with the switching chassis here, the green piece here, and that's where obviously all the hard work gets done in terms of getting the packets to move from one place to another.
And so this goes to, it's just kind of close the circle there. When you're talking about the flexibility you need, right? That's the modularity kind of seems the thing, right? As you get into virtual reality, as you get into all these different areas, right? All of a sudden, like you said, these applications change, the workloads change, right? So the hardware is going to have to.
Yeah, and the thing that's nice about this, I think, is one is that the switch is modular. So this is something that, one, just from a community perspective, is this is and will be put back into Open Compute at some point. And for us, it's one that we expect people to kind of take things out of this and kind of assemble it as they need to. So if you need a different chassis, if you don't like the color blue, or if you want a different form factor, or you want 32 ports, or you want whatever, there are going to be ways to kind of they have the ecosystem hopefully start to work together and be able to build things that are going to solve different problems, different use cases out there in the market. And then that group hug board today, it's an Intel board, but if you wanted to put an ARM processor on there or something else in there, you can, right? And you can run different code on there. There's two parts of this thing, which is Wedge is the code name for this project internally. There's another code name of the software stack that's running on this, and it's called FBOSS. And FBOSS is the software system that has all of the modules. It runs on this Linux operating system, and it allows us to basically kind of control this thing. But exactly this, we'll be able to build modules for things like handling VR, or messaging, or deep learning, or whatever it may be that we're trying to invest over this longer technology arc that we're working on.
All right. And do you see, the network has kind of been, as Open Compute and all these things were happening, and servers have been getting kind of, commoditized, I guess, over years. Do you see this having, when this becomes open source, when it's part of Open Compute, and, do you see the switch having the same type of effect on, let's say, the networking market as, Open Compute seems to have had to some degree on the server
Yeah, so it's coming back to the basics here. Is like one is we really, really want to maximize innovation in all of these different industries, right? So what we really care about is being open about the technology developments that have happened, obviously in the rack and the server and the compute and the storage. Networking just is the natural next place for us to be working together. Now, we continue to just always want the best solution that gives us the best and sort of maximal flexibility in our data center, because if we have to build it, it's fine. If we can buy it, it's fine as well. So it all comes down to what's right for Facebook, and in terms of meeting our requirements and price. And so we really think, and I think with Open Compute and with the switch design here, want to just like increase innovation, and we want things to be more open, and we want to be able to move faster.
All right. I mean, is there a scenario you envision at this point where a company like Facebook, I mean, there's always an idea that we don't want to necessarily have to build it ourselves, but can a market keep up fast enough with the pace of innovation that you guys are going through that you could conceivably buy something again off the shelf, or does it have?
I think it's I think it's definitely possible. I mean, these things this is early, right? We haven't seen. We're announcing this today, and it's something that we do expect lots of people to have ideas. There probably is better ideas, right, of how to make this thing better. So whether or not somebody shows up and says, hey, Jay, like, and team, like, we looked at that thing and we can make it 10% better. Here it is, and it's cheaper and it's better. Then like we definitely want to take a look at that, right? We're not wedded into having it to be our built thing. But we do and need to solve our problems. Like we can't let our business slow down because we can't find the stuff that we need. So that's why we've been focused on making sure that we continue to just focus really, really laser focused on building for this flexibility in our data center infrastructure.
All right, great. Well, listen, Jay, we are coming up on time, so
yeah, great.
Thanks a lot.
All right, thanks for having me.
Okay, to keep things moving along, I want to introduce our next speakers.